What we see on screen is the architecture model of a chatting application that we developed using our tool. On the left is a list of its features defined in the same architecture model. The tool can automatically highlight the related architecture elements for a selected feature following its traceability links. The user can further view code fragments in one of these components that are related to the selected feature. All the related feature code fragments are attached with an annotation that contains the names of the related features. The code is highlighted in the same color. In this case, only several code blocks are highlighted, and they all have the corresponding annotations. The highlighting color can also be easily changed. Select the color, save the change, and reselect the feature. The color of the related architecture elements are automatically changed. So is the color of the related code fragments. The tool can also show code fragments related to different features at the same time. They are shown in different colors which correspond to different features. These two lines of code are related to 3 features, which is why they are highlighted with 3 colors in parallel. Before we move on to the next scenario, let's run the chatting application first to see how it works. And later on, we are going to make some changes and run it again. The application has 2 chatting client windows. It allows the user to send text messages. Also, we can choose a message from the template, such as a smiley face, play tic-tac-toe, and view chatting history. Our tool can also automatically update both architecture and code when the related features are changed. As an example, let's remove the chat history feature. Click OK. The tool begins to process architecture and code. The corresponding architecture elements are removed. In addition, the code is also processed. Remember, these lines of code were highlighted as feature-related code in the first scenario we showed you. Now they are all commented out as to-do tasks. Now let's rerun the updated application to see how it works. The chat history button that was at the bottom of the chat client is now removed. Now let's make another change to the features of the chatting application. We are renaming the game feature to be named Tic-Tac-Toe. Click OK. This time the architecture is not changed. However, if we look at the source code, the related code annotations have been automatically updated with the new feature name, Tic-Tac-Toe. In this way, each feature and its design and implementation are kept consistent. Let's use a tool to derive a new chatting application. It does not include features, template, and game. Both architecture and code will be generated. This is a project where the new application will be derived. Here we need to select the project to store the derived architecture and code and specify the name of the derived architecture. Refresh the project. Here we can see a portion of the code in a new architecture file that have been derived. Next, we need to finish the second step, generating code from the derived architecture. Here is the derived architecture. Right-click the canvas, select Map Architecture to Code, and code generation starts. The derivation process is complete. Now let's run the derived chatting application. This is the end of our demo. Thank you for watching.